Welcome back to another special edition of Education Matters here at Workshop. One of the initiatives of New Jersey School Board Association this year is to inform our members on STEM, science, technology, engineering, and mathematics. And I have two guests here with me who will have a booth at Workshop. I have Ed Denton with NJTEA and Shane Evans, who's a teacher in Howell. Sorry, I forgot your name there, Shane. Ed, what is STEM really, and also what's NJTEA?
Okay. It's New Jersey Technology Educator and Engineering Association. And it's more commonly or easily referred to as NJTEA. And in regards to your question about STEM education, STEM is the combination, if you will, of the collaboration of science, mathematics, engineering, and technology.
And it's more than just, well, in my kids' school they'll say, well, we have science, we have mathematics. Is that good enough to be a STEM program?
Well, if I can use a popular analogy that's used in business and industry today, quite often they talk about people working in silos. And what a lot of American business and industry has done today is try to remove silos. So the accounting department works with the engineering department, works with the shipping department, works with the production and the marketing department. Yet if you take a look, and if this is a desired way for the future of America to work, isn't it interesting in American schools today that we turn around and we've got mathematics in its own silo, science in its own silo, engineering, technology, language arts, etc. So what STEM education does is it allows in a collaboration, if you will, between all the academic areas into some practical problem solving.
Okay, Shane, I've been at your booth, all the booth there, and the kids are very active in the robotics programs there, and it's very, very hands-on. What is it like in a classroom, in your classroom?
Well, depending on the course I'm teaching at the time, it would be something like architecture or electronics or something with tech design. We really focus on the students getting hands-on experience and learning the entire process of the design. So you look at a problem in the world and you have to identify that problem. And then they look at that problem, they go ahead and they say, all right, well, what do we want to solve? What do we want to create out of this problem? So then they have constraints. They have to work within a budget, they have to work within certain materials or different things like that. And then they come up with different research. They go ahead and they look at what's already out there, what could be used that we have to create a new product or to create a new solution to this problem. They test different materials using science and math. They might do stress and strain tests and things like that. And then they would go ahead and come up with some sketches, some solutions to the design. And then after that, they would go down to the next step and actually prototype. So they'd make one design that would solve this problem, and they would test that. And they would see if it fixes it. If it's, let's say they need to race a car the fastest, or they need to lift up a basketball and throw it in a hoop with a robot, they would see if that solved the problem. If it didn't, then how can you fix that and make it better? Or if it did, how can you go ahead and make it even better than that? Like the iPod wasn't perfect the first time. We started with a rolly wheel, actually 4 buttons and a roll wheel. Now we're up to touchscreen. So there's always ways to continue and add more and more to that design. And then you go ahead and they do presentations. And so they're able to get every aspect of STEM into one project without keeping it in that silo.
Do you work with other teachers on these programs?
A lot of times we do. We try to keep in line with some of the science and math teachers. So if we're doing something with rockets, for instance, we might go ahead and have the kids design a rocket that needs to save an egg. An egg has to come back down in one piece. We work with the science teachers to talk about the propulsion system, maybe how fast, acceleration, gravity, and different forces of nature on that. And then we work with the math teachers to bring in algebra, bring in physics, or calculus, bring in different forces.
Ed, hearing what Shane has to say, I mean, it's actually like a work experience, a work project that still covers the curriculum that you need to cover. Am I getting that correct?
Yes, it does. Another way to take a look at it is an awful lot what occurs in the core academic areas. The math, the science, the language arts, the social studies. The areas of STEM allow those things to be used in practical problem solving. There's a pragmatic aspect to what STEM does.
Shane, a lot of times we hear about gender inequity, females in science. Is this a good way to get the females? I mean, I know that all the kids are excited, but Does it help the females get more excited into it?
Absolutely. We've kind of merged from industrial arts, which was very shop, that's a boys kind of class, and we're kind of merging into the technology. So there's a couple organizations like TSA, Technology Students Association, which allows kids from all over the place. They can be freshmen, they can be seniors, there's middle school, and we have different projects based on different interests. So there might be a girl doing an architecture project who also is doing a robotics project, who also does fashion design. We have boys who do fashion design as well. So it allows everyone to choose what they like about it, and it keeps everything on the same playing field. And there's really no focus on like home ec versus engineering. It's all included in one.
Now, I interviewed some kids with the robotics. That's after school, but what you're doing is actually in the classroom during the regular.
Yes, and we also have after-school programs that we're able to incorporate into our classroom.
That kind of complements what's going on in the classroom.
Absolutely.
Ed, if someone wants to, they're looking at this, they're a school board member, maybe a school administrator, and they want to evaluate their current program or make it more STEM related, how do they go about doing that? Can you guys help with that?
Well, one of the things that I would suggest, yes, first of all, to answer that question, is an association. We'd be glad to assist anybody in New Jersey that would like to become acquainted with STEM and the advantages of STEM. In terms of the value of STEM, in a previous conversation we had mentioned that STEM grew out of a nation at risk. People might be more familiar with Thomas Friedman's book, The World is Flat. STEM basically addresses global competition and the U.S.'s position in global competition. So if you take a look at the benefits of somebody that's engaged in STEM, it's where people can use theoretical coursework such as mathematics and science and wind up using engineering and technology to solve real-world problems. So that's what we bring to the table. Theoretical academics married to real-world problem solving.
And how do they contact you?
Well, they can go on to the association's website, which is njteea.org. They can find information from there. We're members of a parent organization, the International Technology Education Educators Association. That's at iteea.org. And they can also go out and just do a Google search to STEM and STEM organizations, and they can find a plethora of information from a variety of organizations and industries that addresses STEM.
Thank you. I'd like to thank Ed and Shane for joining me. And as I said, New Jersey School Board Association will be pushing and informing you on STEM through the course of this year. And if the kids in Shane's classroom were as excited as the kids I saw on the floor here, I think it's worthwhile.